Welcome to another fine episode of AP Computer Science. Make sure you have your notebook and writing utensils handy. Recursion is the process of a method calling itself as a part of the solution. It's a problem-solving technique that can turn long, difficult solutions into compact answers. With each recursive call, the problem becomes simpler and moves towards what's called a base case. A base case is when the solution to a problem can be calculated without any more recursion. Recursion involves the use of a stack. A stack is a data abstraction that works like this. New data is added to the top of a stack. When the information is removed from the stack, it is removed from the top of it. The recursive calls of a method will be stored in a stack and manipulated in a similar manner. Figuring out factorials is a great way to explain recursion. The factorial operation looks like this. Notice that each successive line can be solved in terms of the previous one. For example, 4 factorial is the same as 4 times 3 factorial. A recursive method to solve factorials looks like this. Notice the recursive call in the last line of the method. The method calls another implementation of itself to solve a smaller version of the problem. The method will continue to do this till the end value is equal to 1. Like I told you earlier, the base case is a situation where no further problem solving is necessary. In the case of finding factorials, 1 factorial is by definition 1. No further work is needed. Each recursive method must have at least one base case. So suppose we call the method to solve 4 factorial. This will result in 4 calls of the method fact. When a recursive call is made, the current computation is temporarily suspended and placed on the stack with all its current information available for use. The method will work its way down to the base case, then work its way back up. So for 4 factorial, the method reaches the base case of 1, then does 1 factorial, which equals 1. And then it moves on to 2 factorial, which is 2 times 1, equaling 2. 3 factorial is 3 times 2 factorial, which equals 6. Then, it finally does 4 factorial, or 4 times 6, equaling 24. Notice that when the recursive calls were made inside the else statement, the value fed to the recursive was n minus 1. This is where the problem was getting simpler and eventually got to 1 factorial. Now beware of some pitfalls of recursion. If it never reaches the base case, the recursive call will continue until the computer runs out of memory and the program crashes and burns. The message stack overflow error, or heap storage exhaustion, indicates a possible rogue recursion. Now I want you to know recursion takes some time and practice to get used to. Yet recursion is still a very powerful programming tool for solving difficult problems, and once you get used to it, you can do some pretty powerful programming.